guys, Mr.Cram here. So if you look at the right there, you see a picture of this guy Empedocles, and he lived from 490 BC to 430 BC, a long time ago, over 2,000 years ago. Why do we care about him? Well, he was he's given credit at least anyways, the originator of the idea that there were four elements that everything was composed of. So yourself, the rock you kicked on the ground, everything was made up of these four things. And those four things were air, earth, fire, and water. Now, you are familiar with all four of those things, but you should know that we don't consider those things elements today. So it's inaccurate to think that the bunny rabbit here is made up of different amounts of fire, air, water, and earth, and depending on the ratios, you'd get a different thing. That's not true. We know that's not the way it works today. But that was, a first step in the right direction for where science was going. This idea, though, lasted for way too long, into the Middle Ages. For a couple hundred years, we thought that everything was composed of these things, and we started adding other little pieces. Ether made it into the equation for a little bit. But nowadays, this idea that these four things make up everything is totally not true. We have these other things we call elements now that are on a table, the periodic table of elements, and that's what we're going to talk about today: elements and isotopes and ions. So why is this important? What do we care about elements and isotopes and ions? Well, they're kind of the basic starting materials for understanding the behavior of all the other stuff we're going to learn about this year. So if we have a really good understanding of what makes an element different from a different element, what an isotope is, what an ion is, and really it has something to do with the subatomic particles of protons, neutrons, and electrons for those things. We're going to be doing really well if we can understand those things. So that's our starting point. We're going to use the periodic table to help us understand these different things, these elements, isotopes, and ions. And we'll talk about how we can use the periodic table as a tool. We don't have to memorize it. We just have to know where to find the information in this table. Okay, so let's start with elements. Each element is a unique atom defined by the number of protons in that atom. So every single element, every different symbol you see on the periodic table, hydrogen, helium, oxygen, nitrogen, they're all these different symbols and names because they have different amounts of protons in them. We say that those are different by their atomic number. So if we look at this beautiful bismuth crystal here, bismuth's atomic number is 83. So how many protons are in bismuth? There are 83 protons in bismuth. That's what that number means. That's what we're going to refer to when we're talking about the number of protons, the atomic number. Now be careful, some periodic tables have the atomic number elevated, others have it below. Really, you just have to recognize that the smaller number always, will be the atomic number. The bigger number we'll talk about in a minute. Isotopes are groups of atoms that contain the same number of protons, but different numbers of neutrons. So if you look at the example here, we have three different forms of hydrogen. So there's H1, H2, and H3. They all have different names. We got protium, deuterium, and tritium, and we call them isotopes because they are the same elements. They all have the same symbol here, and we know they're the same element because they all have how many protons? 1, which is the atomic number for hydrogen. But what's different for each of these guys is their mass number, or their atomic mass number. So hydrogen 1 has a mass number of 1 because it has just one proton. Hydrogen 2 has an atomic mass number of 2 because it has one proton and one neutron. 1 plus 1 is 2. Hydrogen 3, or tritium, has an atomic mass number of 3, 1 proton plus 2 neutrons now. So really, you can see the differences here in the diagram, that it's just the number of neutrons between the three isotopes here, but those also factor into the atomic mass. So that's what we call an isotope. Same element, same number of protons, different number of neutrons, and therefore different number of different atomic mass number. Okay, on to ions. Ions are atoms that contain a charge. So you can either be positive, a cation, or a negative ion called an anion. Ions are formed by either losing or gaining electrons. It never will be due to losing or gaining protons. If we did that, we would be changing into a different element. So ions are going to be the symbols for the elements, like Na, but we have a little plus sign raised up here for Na, and then chlorine, Cl, with a little minus sign here. And in a moment we'll talk about which ones are plus and which ones are minus, and we can use the periodic table to figure that out. Okay. Don't forget, in a little way that I remember, that the difference between which ones are positive and negative. Cations are always positive. So look at the paw, it's positive, that's a cation. If you remember that, you'll remember anions are negative. Alright, so how do we know which elements are going to be the positive ones, the positive ions I should say, the cations, or the negative ions, the anions? So you can use the group numbers. Remember, if the groups are the columns that go up and down in the periodic table. So this is group 1A on the periodic table, the alkali metals. And it starts off with really hydrogens missing. It should be on the top here. But we have lithium, sodium, potassium, rubidium. And notice what's the similarity between them. They all have a +1 charge, right? If you go over to group 2A, starting with beryllium, Be, again, we have a pattern as we go down the group. The charges are all positive too. If you skip over on the periodic table to group 3A, that's with aluminum here, okay? So they all have a +3 charge. So notice the group number is giving you some information here, right? One other piece of information you got to pay attention to is the fact that these elements on the left side, the alkali metals, the alkaline earth metals, group 2A, and then group 3A, they're metals. Those are the elements that are going to be the positive charged ions, okay? When we get over to group, where are we at, 5A, starting here with nitrogen on the top, notice he has a -3 charge, right? Group 6A, going down, they're going to be all -2. And then finally group 7A, they're all -1. Notice with both the +1 in group 1A and the -1 in group 7A, we don't write the 1, right? We just use the sign to indicate 1, +1 or -1. Okay, so again, going down the groups, you can get information about the charges on the ions. You should be familiar with that. And know that the group number tells you some information about the charge that ion will make. Alright, so let's practice a little bit. You might want to pause the video on this screen and get some scrap paper out and just kind of jot down here your answers real quick, and then in a few moments I'll go over them. Okay, so hopefully you've had time to practice, and you want to now take a moment and review your answers for these isotopes and ions, and for the atomic number, mass number, protons, neutrons, and electrons for each. Alright, so we'll start with chlorine 35 and chlorine 37. So you should recognize right there the same elemental symbol, different numbers here. These are isotopes of each other, right? Alright, so you look up chlorine on your handy dandy periodic table. The atomic number for chlorine is 17. So that's what you should have written down in both of these. The atomic number will be exactly the same because they're the same element. Protons, that means they're going to be exactly the same, right? It's still chlorine. It's still the same element, so they're going to have exactly the same numbers. Okay? Mass numbers are indicated right here. So the mass number for 35 is 35. The mass number for chlorine 37 is chlorine 37. That's the difference. That's what makes these two isotopes unique. Number of neutrons. Okay, so now we have to do a little math to figure this one out. The mass number, the atomic mass number, is made up of just two things: protons plus neutrons. So if we know that we have 17 protons and we know the mass is 35, I can either say, all right, what's 35 minus 17? Or what do I add to 17 to get to 35? And hopefully you realized that's 18 for chlorine 35. And then for chlorine 37, it's 20. So you should have two different numbers here for the number of neutrons for both these isotopes. Finally, electrons. Now be careful with this one. Electrons are not important here. Okay, these are isotopes, they're not ions. So when we are dealing with isotopes or any other regular element, we're going to assume it's a neutral element. And therefore, the positive things, the protons, have to match the negative things, the electrons. So we have 17 electrons in both of these. All right. On to our ions. All right, so we have an anion up here, O2 minus, and Na plus, our cation below. Okay, so atomic number, we just look up the symbol on the periodic table for this one. So O, atomic number is 8, and then not nitrogen, sodium, Na is atomic number 11. For mass, we're going to do the same thing. On the periodic table, you're going to see some decimal points, right? So O is 15.999. We're going to round that up to the nearest whole number, 16. And then for sodium, it is going to be rounded to 23. All right, protons. We know that's equal to the atomic number. So we have 8 protons, and we have 11 protons for sodium plus. Okay, remember with ions, it's not the protons that change, it's the electrons, right? Neutrons, here I just have to add again. What do I add to 8 to get to 16? It's going to be 8. Or I could have done 16 minus 8, which is 8. Here I'm going to add to 11. I'm going to add 12 to that to get my 23. And now here's where we're going to have some differences, right? So pay attention to the charge. If it's a minus charge ion, an anion, that means that this thing gained some electrons. It would have had 8 to neutralize the 8 protons before, right? So if it gained 2 from 8, now it has 10. Okay? Sodium, he has a plus charge here. That means he lost an electron. He now has one more proton than electrons. If I know I have 11 protons, that must mean I have 10 electrons now. Now this is a cool feature too. When you have ions that are different elements, different charges, but they have the same number of electrons, we call that isoelectric. So I'll try my best here to write that out for you. Isoelectric. Okay? And all that really is telling you is that they have the same number of electrons. Okay? So that's a term you'll see sometimes in a textbook or maybe a test question. Okay? So there you go. What should you have learned? So all elements have a unique atomic number and therefore a unique number of protons. You should know that the atomic number is your best friend for protons. Isotopes, those are going to be the same element but different number of neutrons. So the same number of protons but different number of neutrons, therefore different atomic mass numbers. Ions are going to be when elements have either lost or gained electrons. And therefore become cations if they lost electrons, or anions if they gained them. And then finally, the periodic table is a tool we can use to figure out how many protons, neutrons, electrons are in these things. And sometimes the position on the periodic table will tell us information too about whether an element is going to be a metal or a non-metal. And we'll talk more about that in future videos. Hope that was helpful.